Hello, everybody, and welcome to today's virtual event, Dynamics 365 Tech Talk, Performance Best Practices and Patterns for E-Commerce, Dynamics 365 Commerce. My name is Brad, and I'll be your moderator today. We are broadcasting this session through Teams Live events, and the audio can be heard through your device speakers. This session is being recorded on behalf of the Microsoft Corporation. When you join this event, your name, email address, and/or phone number may be viewable by other session participants in the attendee list. By joining, you're agreeing to this experience. The recording of this session will be available on the Tech Talks Community Dynamics page within the coming weeks. If you have questions for the presenters or need support, please use the Q&A panel located on the right side of your screen. Our presenters will be responding to your questions throughout the session and during the Q&A segment near the end. Thank you for your patience during these announcements. Presenting for us today from Microsoft, we have Srinath Sundaresan, Senior R&D Solution Architect, and Pranav Kumar, Senior R&D Solution Architect. Srinath, over to you.
Thanks, Brad. Hello, everyone. My name is Srinath, and I am joined by my colleague Pranav to present this tech talk. Let's get started. When developing customizations for Dynamics 365 Commerce, it's crucial to consider the performance of the e-commerce website. The goal of this tech talk is to discuss the architecture of the e-commerce framework, pinpoint potential bottlenecks or areas where performance issues may arise, and then review the best practices and patterns for improving performance. However, we will not be covering the basics of e-commerce development, configuration, or deployment. It's important that you have a solid understanding of e-commerce fundamentals, such as the SDK for developer extensibility, custom modules, data actions, themes, and so on. Although we will provide brief explanations of the concepts such as modules and data actions whenever possible, we assume that you are familiar with the fundamental concepts and want to delve deeper into optimizing your e-commerce instance for best performance. During our discussion, we will highlight some of the patterns that were discovered while addressing performance issues. Just a quick reminder, we are building on what we have already done and planning to bring new content to the Tech Talk. We have learned a lot from our past Tech Talks and the Dynamics 365 implementation guide. If you haven't checked it out, I suggest you do, as there are many things we talk about in this series that are covered in the guide. You can download the guide from ak.ms D365 implementation guide. Just a quick overview of e-commerce architecture before we go deeper into performance topics. The request from the client first reaches the rendering platform layer, and the platform does authentication, routing, and local detection. For example, if you are requesting for product page or category page, the rendering platform will first try to identify the list of modules present in that page that were configured on the site builder. Then the platform talks to the CMS, content management system, fetches the page saved which contains the list of modules and the app settings, theme settings, module configuration information. And then it sends that information to the node layer, which is the commerce app. We will get into the node layer in detail shortly. The node layer receives the request and then pulls out the e-commerce package, the view extensions, definition extensions, information that are deployed, and then identifies the modules. Each module can also have data actions. The node layer runs the data actions and talks to the retail server, fetches the data, and passes the data to the modules, and then invokes the React render library. The React render library renders modules on the server side and returns the HTML response back to the rendering platform, which returns it back to the client. So if you notice here, what we are doing here is that the entire modules is rendered on the server side. Now, this is something important to remember. And the other thing to note here is if you look at the pipeline, any latency here, for example, if a third-party API takes more than the expected time, let's say if it takes 5 seconds, it will impact the overall request time. So these are some of the obvious performance bottlenecks that can happen, and we will cover more details in the coming slides. Now, going into the node layer a bit in detail, So the node layer essentially contains customizations, extensions, which is built on top of the modules library, and which again is built on top of the SDK. Starting from the bottom, SDK defines the module structure. How should a module look like? What are extension points a module contains, and various other components. On top of the SDK, we have out-of-the-box modules, which contains all the modules that we ship out of the box. On top of that, we have customizations or extensions. The customers partners take this SDK and module library, and they create their own customizations, and they create their own custom modules or extensions. The compiled package contains both the SDK and the module library. The SDK isn't extensible, but module library modules can be cloned and completely customized. And this app is again built and packaged by the SDK, and then this package is deployed to your online environment by using LCS. Once the deployment is complete, then based on the page configuration, the node layer starts looking into these modules and then renders them on the page. Here is a quick overview of the data actions. Data actions are small code snippets which are used to fetch data from retail APIs or third-party APIs, and then the data is fed to the modules. They provide three very powerful features that allow simple functions to scale into the large and complex applications: caching, batching, and deduplication. There are a list of core data actions that are included with Dynamics 365 Commerce Online SDK. These set of core data actions can be called from modules to do typical data retrieval. For example, core data actions can return product details, get customer details, etc. You can also create custom data actions to fetch and process data that is required by the modules. Now let's go deeper into the rendering part. We have both server-side and client-side rendering. The reason why we have server-side and client-side rendering is because the application is isomorphic. So we have server render where much of the page, almost the entire page that we see during the initial load, everything is rendered on the server side. And then on the client side, hydration happens. On the client side, it is simply called as hydration. This is a React concept where React takes the rendered page and then simply attaches the event handlers. So it's optimal compared to the render where it must generate the entire render tree. Hydration does not generate the whole render tree. It just iterates over what is rendered on the server and then simply attaches the events. On the server side, this is the flow. So we fetch the data, we render the HTML, and then we emit the script tags. And on the client side, the hydration happens. There is a reason why we are having server-side rendering. One reason is SEO optimization, and the other reason to reduce the page render time. The driver here is to move any performance-intensive operations on the server side, because servers are like more powerful than the client browsers or client machines. So we should be using server-side rendering as much as possible. At the same time, it is a delicate balance. Make sure not to spend a lot of time on the server side as it will add to the latency of the request. Whatever we see during the initial load in the visible screen, it should be rendered on the server side.
Let's now go to adventureworks.com. There's a simple trick to check what is rendered on the server side. I'll block the JavaScript and then refresh the page. So if you see here, pretty much the entire page is rendered on the server. There is literally nothing that needs to be rendered again on the client. Right now, when I disable the JavaScript, obviously the page is not interactive. You cannot click on any of the click events and everything is disabled. Until the hydration happens, these do not work. The hydration processes the JavaScript, identifies the components, and then it prepares the render tree on the client. To enable client hydration, the server also emits a blob called initial data. This data is the same data that we used on the server render. The same data is passed to the client so that the React render also happens on the client. Now, what this blob contains is a request context object and any data actions that were executed on the server, any platform settings, app settings, information, etc. Along with this, we have the MS-DYNE 365 object. This object contains request details after the client render has also completed. It can be useful to check if there are any differences between the MS-DYNE 365 and the initial data objects to determine whether there is a mismatch between the server and client-side renders.
So how can the render behavior be controlled? We can control a module render behavior by using the RunOn configuration. The setting is in the module definition. So if we set a data action to run on server, the action will run on the server. And once the data is available on the server, the module will render on the server. If you set it to client, then the action will run on the client and the module will render on the client. The data actions are not aware of which module they are associated to. Data actions have no knowledge of how many modules have dependency on it. In one module, it may be configured as a server side. In a different module, it can be configured to run on a client side. Different modules can place different demand on how the data action should be executed. When the system try and processes that on the server side, we basically give precedence to the server side. Even if a single module says that it wants the data action to be executed on the server side, we will execute the data action on the server side. We will make the data available and the module can choose to whether use it on the server side or client side, depending on how the code is written. On the module render, the developer must check if the data is not there. They simply must return an empty tag or something that once the data is available, only then the valid code path with data should be used. When we say client-side rendering, we are referring to using JavaScript to display information on the web page. Dynamic 365 Commerce renders pages server-side and hydrates the page on the client after the initial load. Unless there are some exceptional cases or business requirements where we need a module to be rendered on client, otherwise most of the page is rendered on the server, and on the client we do the React hydration. We also send a small JSON to the client which contains the context information required for React to hydrate the page on the client. If the data is going to be available on the client side, the module should not try and access it on the server side, because if they do, then it would result in an error scenario. When something is expected to run on the client side, make sure to handle the object appropriately on the server side also. So the decision to render a module on server and client is primarily based on the API latency. The module is rendered on the server as well, just the data is not available. Where the data action is run, then decides whether we show the data on server or client. Now let's take a look at a few best practices and patterns. The first best practice to keep in mind is to keep the server render time short. It is important to avoid high latency API requests on the server as they could impact the overall request latency. If the server is making an external third-party API request, it adds to the overall time taken to process the request from the client. In such cases, you can defer the data action to run on the client. In the server render, you can have a basic experience, and on the client render, hydrate the module with richer experience. Caching can also be leveraged where the action response can be cached. In the server side, under the node layer, we have an application cache, which is across the requests. For example, if a data action is used on a PDP page and two separate users are accessing the PDP page for them, like the first request will cache the response and the second user will get the response from the application cache. Then we have request cache, where on the same page, if you have a data action which is run twice in two separate modules, then the first action execution is cached for that request. And for the same request, when we have the same data action, we read from the request cache. By default, all the actions are cached at the request level. We talked about server-side and client-side rendering and the initial data that is part of the architecture. It is very important to keep an eye on the initial data and how big it gets. It is also very important to keep the initial data sent to the client optimal. Check for any huge JSON objects defined in the module configuration. For example, we have seen customers often configure external script modules in the module configuration, which have huge JSON objects, and module configuration configs are part of the initial data because the client render and hydration needs this information. The server obviously will send the data to the client, and this will increase the page size, which adds to the page serialization, the compression time, and it will increase the time to first byte. You can always go to the AdventureWorks website for comparison of page size and get an idea relatively like if there is something wrong with the pages. The other factor which contributes to the page size are data actions that can return redundant raw retail third-party response without any transformation. For example, if there is a retail API which returns huge JSON response, most of it might not be used by the module. The module might be using just a subset of the data or aggregated information. If the data action returns the full data to the module, then that will also show up in the initial data and it will increase the payload size. For custom data actions, look at the implementation itself and see if the data can be transformed so that only the actual data that is used in the module is returned. There are some options or configurations to further reduce the data size, data action of the data action payloads that are sent to the client browsers. If a data action result isn't required when a module is rendered, you can set the data action's data cache type value to instance to prevent the data action output from being sent to the client. This approach is useful when a module's parent data action calls a child data action because modules require only the parent data action result. That already includes the child action results. As of Commerce version 10.19, release of the module library, the data cache type value is set to instant by default for all retail server proxy data actions that are typically called from core data actions. Because retail server proxy data actions are now set to use the instance cache, the results won't be sent to the clients and custom modules should not use them directly. Instead, custom modules should use either core data actions or custom data actions that use retail server proxy data actions. Another important performance aspect is parallelizing the request on server side. Synchronous chaining of API requests should be avoided when the module is rendered on the server. E-commerce framework executes independent data actions parallelly. However, data actions which are of the nature of aggregator, which depend on other data actions, can create a chain and add to the latency. Such actions should be designed with care to not derate the request latency. So if we have a data action which is chained, then like one action is waiting on the other action to complete, then in those cases, this will increase the request latency. By default, SDK already runs these data actions independently, and out-of-the-box actions are also optimized to not have any unnecessary chains. In scenarios where it is mandatory, then in those cases we can have chains, but those should be very short chains. If you have chain action, then one action will depend on the other action to complete, and which will increase the page response time. Next pattern is to ensure SSR for modules, server-side rendering for modules that are part of the initial load. We briefly touched upon this already. If the API is performant, if there is no latency, all the modules during initial load must be run on the server side. The best thing to do in this case, if the API latency is high and it's impacting the request latency, then defer the module to run on the client. The RunOn configuration can be set on the data action to control the module render behavior. One of the biggest performances to a web page can be downloading of images. You should use CSS whenever possible to generate images for items such as buttons, but in cases where you need marketing or product images, you should upload the images to the Commerce Site Builder Media Library. Images uploaded to the media library should be of high quality and resolution to cover all website usage scenarios. Images served from media library will automatically be resized using an image resizer service. A performance scenario we usually see with customers is the image settings not configured for different viewports. Image settings are configured per module in the theme.setting.json file. If this is not done, obviously the browser will end up downloading the highest resolution image irrespective of the viewport that is being used. When building modules with images, the HTML should always include the width and height parameter. If the height and width are not provided, image caching will not be optimized through the image resizer. For image types and file sizes, the goal is to find the right balance to maintain image quality while keeping the image size as small as possible. There are techniques available here to use different file formats like JPEG or PNG and controlling the image size by adjusting the resolution of the image, adjusting the width and height, and updating the quality parameters. Modules that show images such as content block module generally don't load the image until they are needed. This lazy loading behavior might cause a perception of performance issues because an image isn't loaded when the user is ready to view it. These type of modules that show images have a configuration setting that lets you disable lazy loading. Images are then loaded before they are needed, and the users might perceive improved performance in those scenarios. A good practice is to ensure that images needing to appear immediately when loading a web page have lazy loading disabled so they appear quickly. Images such as those appearing lower on the page should have the lazy loading enabled. We also have made improvements to the media library module to improve performance by first loading the images on the server side and validating that they exist. This feature has been available since 10.26, and some configuration is required to turn on the media gallery image optimization feature. Caching can also be applied to static elements such as images. By default, images have a content delivery network CDN cache time of 5 minutes, meaning that if a request is made for a particular image, after 5 minutes have passed, it will need to be retrieved from the original source, resulting in a slower response time. However, it is possible to extend the cache time by submitting a support request. Next one is enabling lazy loading for below the fold modules, or in other words, the modules only visible when a user scrolls down the page. Lazy loading defers initialization of resources until they are needed and can make the web pages load faster. A module that is below the visible screen can be deferred to load and render as user scrolls into the view. Note that this is different from the client render where JS is loaded but rendered during client hydration. For example, if we go to a page in e-commerce site, there may be modules below the fold or below the viewing area. Until the user scrolls there is no need to render additional modules. We don't render these modules and don't even download the JavaScript of these modules until it is needed. The page load time is reduced and reduce the amount of time browser spends on processing the JavaScript and rendering these modules. This is a very powerful feature and it has direct correlation with the total blocking time. Lazy loading significantly reduces the total blocking time as both script evaluation and hydration time as a small number of modules are hydrated during client-side rendering. All the modules, whether it's custom or out of the box, have lazy loading property, and you just have to turn it on through configuration. We have seen scenarios where customer implementations invoke retail APIs repeatedly from the client or have significant latency due to custom extensions. In such cases where the action can be cached, does not involve any user context, AJAX actions feature can be leveraged to invoke the action on the server via AJAX and retrieve the response from node. The Dynamics 365 Commerce Online Software Development Kit SDK supports using AJAX to invoke server-side data actions from the client browser. This feature can also be used in scenarios where data actions contain sensitive information such as API key or secret that is required to call a third-party service. Now I will give the control to Pranav to take us through the remaining part of the presentation.
Thanks, Srinath. Just a second. Thank you, everyone. The first topic that I want to talk about is pagination parameters. For modules that use retail data action to return search, list, or other paginated results, the recommendation is to use that you use top-end parameters, and it is optimized, and as that is optimized for web performance. For example, like by default, the retail API requests are configured to retrieve top 1,000 results, but retrieving high number of results will impact API latency as more time will be spent on gathering the results. But in cases like, for example, the product search result, you may want end customers to see maybe like 30 to 40 products when the page loads. And in that case, retrieving 1,000 results may not be optimal. And that's where this parameter becomes important. If you don't set the top end parameter for a module, the data action will fall back to the default page size app setting that was defined in the site builder setting under extensions general, which is I've highlighted here also. If that setting is not configured either, the fallback will be the default value that is set on the retail API, which is generally high. So we would recommend that you set up the top end parameters for modules or given in the site builder. For custom data actions, the top end can be overridden using the query result setting as we have highlighted here. Okay. So after top end parameter setting, the next topic is use caching. Caching is one of the first avenue that comes to mind, like when we talk about performance. And caching is often used on static content that does not often change, such as images, product content, and JavaScript and CSS files. Some scenarios may require custom cache setting to achieve the best performance results. In D365 e-commerce offering also, the caching configuration can be divided broadly into three different categories. Number one is like data action caching. The data action caching can become very important when queries with same parameters are executed like product catalogs, right? So, that improves the performance. The second is image caching, kind of what Srinath also covered. Like as you know, the image caching is the copy of the image can be stored on the network node or on the device for faster retrieval of the image. That helps with the bandwidth. Okay, and the next and important is page caching. Page caching enables the e-commerce site pages to be cached on the server. From which they can be served to the site users, significantly improving performance time. Page caching and caching duration can be enabled and configured in the commerce site builder for site pages, or alternatively can be configured for templates that are applied across multiple site pages. So this is something you can decide when like implementing e-commerce. We will zoom in a little bit on the cache paging anyway. With regards to data action caching, the product-specific data is cached in the e-commerce rendering node layer. Caching times are different for each entity type and can be configured inside of the cache setting.json file in the SDK. After these entities are cached, they are returned from the cache for all the data action requests that have the same cache key, provided that their name, that their time to refresh and time to live values are valid. For core data actions that are provided in the SDK, the cache key is simply like set within the data action itself. For custom data actions, the cache key can be defined in the action input by overriding getCacheKey method. The slide that I'm showing up here, it shows a JSON file that includes a section of TTR and TTL setting for data action cache. Each section contains name of the entity that you can see here for the data action cache key, followed by the time in seconds. Please note that the examples shown here might differ from the file that is included in the SDK because the SDK is regularly updated. And we also recommend to ensure that the cache keys are specified correctly and should match. Otherwise, the cache setting will not be applied. So for example, if you see the first value here, the attribute value, if you call it out like attribute values, then the setting won't be applied. So just to be careful of this. Coming to page caching, to enable page caching, you must first enable the setup called enable render caching feature at the site builder level. Like I've just highlighted, it's under the extension module here. You then configure the feature either on each page that should be cached or on a template that is applied on the multiple pages. The feature is available under extensions in the site builder module, like we called it out here. And this is a prereq. Like after you enable this, then we will talk about the usage of caching on the page. So in order to configure page caching for a specific page, select the page in the site builder, and then select default page module in the module hierarchy to open the module properties pane on the right. This is like behavior. If you see the red highlighted screenshot here, the cache page server side can be checked. Okay. After you enable the caching for a page, it's turned on for that page, and two additional properties appears below the cache page server side. The server side checkbox in the properties so that you can configure cache times. The first is page cache TTL. This required property describes the the absolute time we know, right? I mean, in seconds that a page should leave on the server in the cache before it's removed. The page cache TTL property should be appropriately specified. You can adjust the numbers as required. In this case, after a page is computed and saved in the cache, any request on the same page that occurs after the specified time should not use the cache result. So instead, the page should be recomputed. If no values are set, then caching won't be applied. So the takeaway is, for both page cache TTL and page cache TTR, in the slide I've just shown up a default values, but it may depend on how you want to set up your e-commerce. So the similar is the behavior of TTR as well, page cache TTR that we talk about the TTL. Okay. Now, please note that some modules, such as product collection module, support a configuration setting that ensures that the module is loaded on client side. The product collection modules uses context to support queries such as best specs for you. However, because this data will be different for every user, you don't want it to be cached. In this case, if the page is cached, you should enable the module lazy load property to ensure that the module is loaded on the client side. Next important topic we want to talk about is Web Vitals. There are 4 different components that we monitor when it comes to Web Vitals. Number 1 is FCP, which stands for First Contentful Paint. This metric measures the time from when the page starts loading to when any part of the page content is rendered on the screen. For this metric, the content refers to any text, images, elements, or non-byte elements. Usually, FCP score is good from what we have seen normally, mainly because most of the rendering happens at the server side. And in case if there is a module page render, failed at the server, then we see the FCP numbers go high. So one question often being asked is the benchmark on the FCP. There is no direct answer to it, but because it depends on the sites that you are building. But one suggestion we gave is to compare the FCP numbers of your site with the production AdventureWorks site. Now, please note that in your case, the FCP numbers can be lower or it can be higher than the AdventureWorks site. It all depends on how the page is designed and what is the page size. Okay, so for example, we know the events like if there is an inventory check, if there is a recommendation calls on the page load, that increases the FCP score. If you remove some of the features on the page that is not required, then you will see that the FCP scores gets better. The second vital that we monitor is the TBT, which is like total blocking time. The metric measures the total amount of time between first contentful paint and time to interactive. So this impacts the perceived performance of the user. The ways to improve TBT is looking at the unused JavaScripts, we'll say, similar to what we have discussed in the, we will be discussing in like optimize JavaScript bundle size topic today. The third is LCP, like largest contentful paint, and it is an important user-centric metric for measuring the perceived load because it marks the point in the page load timeline when the page remains content has likely loaded. So, for example, like the render of image taking more time can attribute to it. Similarly, if there are videos, then the load time can generally be high, and the LCP score can get high. For a good LCP score, ideally the content should be rendered at server side. This score has UI impact as well. So LCP in general will be not good if FCP and TBT numbers are also not good. So you can, whenever you have situations like you want to improve the LCP numbers, then you may want to improve the FCP and TBT numbers also. The next is the CLS, which is like cumulative layout shift. It's an important user-centric metric for measuring visual stability because it helps to quantify how the users experience unexpected layout shift. A low CLS can helps ensure that the page is delightful. So we have, for example, like we know, right? We have server render and client render. So between these two, it tries to see if there is any layout shift that happens. If this is high, then module might be doing some something unusual at the client render, which means it's running some code at the client level, and it creates a jarring experience for the users. User should see some differences. So that's the CLS. Now let's talk about the Java bundle size and its optimization. So JavaScript bundle size has significant impact on the total blocking time as the process spends time in evaluating the script blocking the render. Some recommendations for this topic that we want to share. So at first, ensure that enable module entry point is enabled in your case. Second is check for any unnecessary dependencies or dependencies that bloat up JavaScript chunk size. You can also consider reducing unused JavaScript on the site. The Commerce framework supports generating JavaScript bundles per module and loading only the bundles that are needed on a page. So the enable module entry points platform setting enables the generation of JavaScript bundle per module. The other scenarios related to slow performance is due to dependency on third-party packages. And third-party packages can bloat up bundle size. It's actually in one case, it's like one customer cases, we have seen that there was a dependency on third-party bundle size that attributed to the website's performance. So in order to solve this problem, what we can consider is first point is can the dependency be avoided by a simple helper function? Or the second thing is there an alternative that can be used instead of using a big size package? Okay. With regards to optimize JavaScript bundle size, you can evaluate the JavaScript bundle size in use. To evaluate this, you can run analyze prod build command in packet.json. It's here. So once you run this command, what happens? When run locally, it will list out dependencies and size of the JavaScripts. So this gives an indicator, and this gives an indicator, and you can zoom in the results as the content is very rich. So in the slide, you can see, which are the bigger scripts with details of the size, and it's in descending order. So the top left here is the biggest JavaScript, and the bottom right here are the smaller ones. So it's kind of, like heat map, and it shows you what the sizes are. So the files which are bigger are the files that you may consider optimization, if possible. So now let's talk about browser hint tags, which is again important performance related topic. So browser hint meta tags such as pre-connect and DNS prefetch can be used to tell browsers what resources are needed ahead of time to render a page. Now, those tags will cause a browser to initiate a network connection before it's typically would, to make time-expensive network calls earlier. This is helpful for adding additional render of images, font, or file endpoints used within the page. The pre-connect browser hint meta tag can be used if a page relies on resources coming in from external origins or domains to initiate a TCP connection. So the next is like DNS prefetch also, like browser hint meta tag can be used if a resource is likely to be navigated to or used on a page. DNS prefetching can restore a domain's address earlier than usual to avoid this time-expensive step later. Sorry. Now in the screen, like you can see, like meta tags can be added on a page in Commerce Site Builder using the meta tags module. So go to the HTML head and you can click on Add Module. And once you click on Add Modules, then you will see the option for meta tags. Okay. And then you can take the work on the next steps, like clicking OK, saving and publishing, etc. So Webpack 5, the Dynamics 365 Commerce Online SDK supports using the latest Webpack 5 release to bundle the commerce application. Webpack 5 offers improved bundling together with better tree shaking and code generation to reduce the amount of JavaScript that is downloaded and processed on a page. As you know, tree shaking is a process of removing dead code, and and it will and that is not being used and application, but it is there in the code. So Webpack 5 identifies those code during the build, and so those are the steps through which it improves the performance. Now Webpack 4 used to do that, but Webpack 5 is better. So new customers who are taking latest code are already on Webpack 5. Existing customers may still be on Webpack 4. So we do the commerce version if you are on 9.41 on the CSUs or 10.0.31 application version, then you have Webpack 5. If you don't have Webpack 5, we recommend you can run the command to switch to Webpack 5. The next topic is optimize CSS. Until recently, like we bundled all our CSS into one big CSS file. Due to this, there was some unused CSS code that gets downloaded on browser, and browser spends time on downloading and passing CSS, which had a negative impact on the performance. So now we have a solution to this. You can run the opt-in command called enable module CSS optimization. So once you enable it, you can run the command you can run the command for optimization as shown in the slide. This is a command here. What this command will do, it will look at all the modules that customer has and generate the structure for CSS. Please note that this command is not expected to refactor all CSS code. We will say maybe 75 or more % can be done. Existing customers might have to do some additional dev work to restructure the CSS. So this involves some development work. If you are going to use it in case the site is already live, please consider testing it thoroughly. If you are in a development phase, then I think this is a good time to consider it. The next, and we often see this is the unused code problem at the client side. Unused code can be impacting performance if not checked. The problem statements from the customer, that we have seen is the build time is high. Okay, so what we have seen is like we would recommend to check for old unused modules themes that are no longer used on the site, as this could contribute to the performance, right? And remove them. That's a main point, to remove unwanted code themes styles from the production code. So some key points from today's discussion, it's very important that e-commerce site pages be performance tested before they are go live. You can use wide range of existing tools for web page performance testing. At a minimum, you can use the web browser's F12 developer tool to examine the network loads for individual parts of the page. Some of the tools that we normally see people use, and it has been in use, like Lighthouse, Power Speed Insights, Web Page Test. Okay. The second thing is the recording of this session will be available on community.dynamics.com along with the presentations copy. So use this PPT, we will share the PPT and the session recording as a handy tool when it comes to performance related troubleshooting. Follow the best practices during the implementation itself. We don't want the performance to be considered like at the tail end of the project. It's good if we can keep performance in mind at the beginning of the project itself. The fourth is even if the site is live and does not necessarily have performance issues, as part of optimization, you can consider some of the points that we discussed today for long run. So with that said, we will open the floor for any questions. Do we see questions coming in, Srinath?
Yeah, there have been questions raised, and I have responded to all the questions. And if you have more questions, please use the Q&A panel to post your questions, and we can respond through the live Q&A as well.
I think if like someone asked any question that we think is good for broader audience, then we can probably call it out as well.
Yeah, so there was a question on can e-commerce work with third-party APIs? That was one question. Pranav, you want to take it, or?
You can go ahead, Srinath. Yeah.
Yeah, so e-commerce can work with third-party APIs. You can have data actions, which can call those third-party APIs. So, I think there was one more question on what all modules use data actions. Almost all modules use data actions, and you can the module can choose to use one or more data actions. We can add that in the module configuration. So that was another one. And just seeing if we are getting more questions or not. Yeah, I think I think we are done. Okay, I just got one more. Is it possible to use a third party? Maybe what you mean is a content management system. So I think that was question. Is there a plan to use a third party content management system? So although not in this context of what we are talking about in the tech talk, yeah, there are some possibilities. So please reach out to us and we can help on that matter. Yeah. And just giving a few more minutes for any more questions. Last couple of seconds. Yeah. Yeah, I think that's it from our side.
On the Q&A side. So thanks. So here are some links of important topics that you can revisit for more deeper understanding. As you know, we constantly update Learn site, so that will have the latest information. And we recommend you to go to the Learn site regularly, even like we have a section for best practices there as well. So thank you everyone for your participation today. We hope it was a productive session. Brad, I will hand it over back to you.
All right, thank you very much. To our audience out there, I have posted a link to a short survey in the Q&A panel. We would love to get your feedback on today's session and hear what you'd like to see in future events. Thank you for your participation on that. As a reminder, the recording of today's session will be available on the TechTalks Community Dynamics page within the coming weeks. And finally, we'll close out today's session by extending a big thanks to our presenters, Pranav and Srinath, and to you, the audience, for joining us today. Have a great day ahead, everyone.